So this is a tutorial about something called functions, and we've talked a little bit about functions in class, but this video should help us understand a little bit more about what a function is and what a function isn't. So we'll talk about that a little bit today. So we have two big ideas that we really want to hit. You should be able to learn to identify what a function is, and the keyword being function is from a graph, a table, ordered pairs, and from a mapping. I'm also going to talk about it from like a real world perspective because I think that helps us give some context into what is actually happening. You should be able to state whether a relationship between two things is a function or not, and you should be able to explain why. So hopefully we'll get through all of that today. So for just a second, I want you to ignore that this is a math lesson and just imagine that you have a free vending machine. So this vending machine gives you soda. When you push the button, you get some soda. I really want you to consider what is the input and the output of this machine. What is the input of this machine and what is the output? And hopefully, as you're starting to think about this, you think that the input and that you know that the input is pushing the button. So our input is going to be all about pushing that button, and our output should be the soda that we get. So in this particular example, in is the button, and out is the soda that we get. Now in this particular example, there's a few different types of soda. There's Blast, there's Slurp, there's Lemon Twist, and then there's Diet Slurp. And these are made up names. So if I, Mr. Germanis, I'm going to go buy a soda and I push the button for Lemon Twister, and then I got a can of Lemon Twister. So that means the first time I went, I pushed Lemon Twister and then I got Lemon Twister. So that's my first attempt. And then later I go back and I push the button for Lemon Twister and I got a can of Blast. Push the button for Lemon Twister and I get a can of Blast. I'm going to ask you the question, is this machine functioning consistently? And I use the word consistently very carefully. I'm not asking if it's functioning correctly. I'm asking if it's functioning consistently. And is this functioning consistently? Well, no, this is not functioning consistently. And the reason it's not functioning consistently is because when I push the button for Lemon Twist, I get Lemon Twist, but when I push the same button for Lemon Twist, I get a totally different soda. So it's really hard to predict what I'm going to get out of my machine and versus what I put in. So the idea of predicting the correct thing is kind of the perspective that we want. Is it functioning consistently? Okay, we've got a couple of examples. So Brandy pushed the top button. Now, she pushed the top button for Blast and received a can of Blast. Miguel decided to be different and he pushed the second button for Blast. He too received a can of Blast. So in this situation, there's two buttons. There's button 1, so Blast button number 1, Blast number 1, and then there's Blast button number 2. And when Brandy pushes the top button for Blast, so we'll call that button number 1, she receives a can of Blast. And then there's a second button that Miguel pushes, and he also receives a can of Blast. Oop, not blank, Blast. Blast. Oops. So both of those receive the can of Blast. Is this machine functioning consistently? Is it functioning consistently? Can I predict what's going to happen? Well, I suppose maybe you need to know another piece of information. Maybe you need to know that when we push Blast number 1 again, I also get a Blast. And when I push Blast number 2 again, we'll do that in here. When I push Blast number 2 again, I also get a Blast. So I push Blast and I get Blast. This seems to be functioning consistently. In all of these situations, I can predict based on the button that I pushed that I get the soda that I anticipated. So it's functioning consistently. Okay, one more, and these seem kind of basic, but this next one is actually where it becomes really important to understand what we're thinking about. So Abby pushed a button for slurp, and she received a can of lemon twist. So I'm going to document that. She pushed the button for slurp, and she gets lemon twist. Later, Tyrasia pushed slurp, and also received a can of lemon twist. So slurp, and also received a can of lemon twist. Is this machine functioning consistently? And I want you to just think about that for a second. Is it functioning consistently? We know it's not functioning correctly, but is it functioning consistently? Now that word is super duper important. Is it functioning consistently? Now, students in my class decided that yes, this is functioning consistently. They just got the wrong soda. But anytime I push the slurp button, I get lemon twist. I can easily predict what I'm going to get out based on the button that I pushed. And so yes, this is functioning consistently. All right, I wanted to take a quick moment before we do a little bit more math related things, is to look over the 3 examples that we just talked about. So we talked about 3 situations. The first where we pushed the button for lemon twist and got lemon twist. Then we pushed the lemon twist button and we got blast. And we decided that this was not functioning properly. Not functioning. Because when we pushed a button, we didn't know what to expect. And then when you pushed the blast button number 1 and the blast button number 2, even though they were different buttons, we knew exactly what we were going to get. It was functioning consistently because we could expect what we were hoping to get. We pushed the button and we got, every time we pushed blast button number 1, we got a can of blast soda. Every time we pushed blast button number 2, we got a blast soda. And then this third example is when, even though that it's not correct in that, like, pushing a button for slurp and getting out lemon twist, every time I push slurp, it is functioning consistently. This is a function because it is functioning consistently enough to the point where I can predict what's coming next. So with this in mind, I want you to take a look at these 3 new examples, and they're a little bit, sorry, the tutorial is crooked just a little bit, but you can look at these 3 examples, and I want you to identify, is this closest to number 1, number 2, or number 3? All of these, these 3 examples with candy and with numbers and inputs and outputs are related to one of these 3 in some way, and I just want you to take a moment to consider how they're related to one another. That they are related in some way. And hopefully at this point you notice that number 1 is that I push button 1 for sticks, I push button 1 for sticks, I push 2 for M&Ns, and 4 gets me M&Ns. So far it's still a function, and it's no longer a function as soon as I get here, because it is very, very similar to problem number 1, where I push button number 2 and I get one thing, and then I push button number 2 again and I get a different thing. So this is not a function. And we can tell because the input does not have a consistent output. Now if I look here at number 2, this second example, and I see, the students in my class usually get confused as soon as I throw numbers at them, but think about it this way. I push button number 7 and I get product number 6, and I push button -2 and I get -3. I push button 0, I get 4. I push button 4, I get 2. I push button 9, I get product number 10. Now, this button and this button is where students typically see a mistake, but notice that this is almost exactly the same as example number 2. Button number -2 gives me product number 3, and button -3 also gives me product -3. Just like our 2 different buttons over here gave me the same product out of my function machine. So this is a function. The second one is a function because I can reliably predict what's gonna happen when I push a specific button. I'm going to give you a second, and I encourage you to pause the video and try number 3 and see, is this functioning consistently, and which one of these 3 examples is it closest to. So pause the video and match this table of values to one of these and decide whether it's functioning consistently or not. All right, hopefully you've had a chance to try it out, but you should notice that we should look right here at 2. Button number 2 gives me product number 9, and button number 2 also gives me product -8. So this is not a function. Now, what could I do? Let's suppose for just a second that instead of -8 here, let's suppose for just a second that instead of -8, I pushed button 2 again and I got 9. This would now be a function because even though I have even though I have the number 2 hit twice, I still get the same output. It's easily predictable. This is much more like number 3 now, but that is not what's happening, and because that's not what's happening, and that when I push button 2 I get 2 different outputs, this is not a function. And so we can't make that happen. So now that we know what a function is, there's a few different ways to map them. And if you're following along in your workbook, this is page 18. This is for the 2018-19 school year. But on page 18 in your workbook for Unit 3, you can follow along with us. But notice that we've got an input and we've got an output. And inputs are linked to specific outputs. So input 6 is linked with output -4, input +5 is linked with output 0, 2 with -4, and 1 with 0. Now ordered pairs come in XY form, so my input is my X, and my output is my Y. So if I wanted to start writing this mapping, this is called a mapping, what you see here, as an ordered pair, I know that 6 goes with -1, so I would write 6, -1. And 5 goes to 0, so my function is 5, 0. And my input is 2, goes to -4, so my ordered pair is 2, -4. My input is 1, 0, so my output is 1, 0. Now, I want to know, is this a function, and how do we know? Well, yes, this is a function. Yes, this is a function because every input has its own output. And I can predict that 5 is going to go to 0, and even though 1 also goes to 0, my button number 5 goes to product 0, my button number 1 goes to product 0 as well. This is a function, it's predictable. So now that we have these 4 points, these are the same exact points as the previous slide, we could plot them on a graph. And so graphs are another way of representing a possible type of function. When I graph a point, I'm going to graph it with ordered pairs. And ordered pairs always come in the form of x, y. So x is my first coordinate, y is my second coordinate. A has the coordinate 6, -1. And so on my graph, I go 6 in the x direction and -1 in the y direction. I plot a point. I plot the point 6, -1, and I'm going to go ahead and label it A. B is labeled 5, 0. So again, I go over x is 5, and my y value is 0. So I'm going to plot a point right there. And I'm going to do it in blue just so that it's a little different. And I'm going to label that point B. And I can repeat this over and over. My C is at 2, -4, so I go over 2, and down 4, -4 because the -4 lines up. 2, -4. I'm going to plot the point C. And D is 1, 0, so I go over 1 and up and down 0. And my point D is right there. Is this a function? Well, absolutely, because all of the previous things were functions. This is also a function. We're going to get to an example where we're not working with functions, but that's just going to take just a moment. So if I wanted to turn this map into a table, it's also really simple. Notice that I have new language up at the top, that X is also known as the domain and the Y is also known as the range. And so I just want to be consistent in knowing that inputs can be called domains and outputs could be called ranges. And just like an ordered pair, 6 goes to -1, so my input is 6, my output is -1. 5 goes to 0. 2 goes to -4, and you can see this with the arrows, and then 1 goes to 0, and that's all of the linkings that I have. And so I can easily make a table of values from a mapping or ordered pairs. You notice that these are exactly the same as an ordered pair. 6, -1, 5, 0. So this is super duper handy for us. This is a whole new set of examples. So notice that we have a different mapping, and I want you to just pause the video and take a moment to link these and make this mapping into ordered pairs. This is great practice. Right. Hopefully you've had a chance to link them together, but -2 will go to -1, 1 will link to -5, 2 will go to -5, and 2 also goes to 0. This is starting to look interesting. 5 is also going to go to 0. Now, if I think about this, is this a function and why? Instantly, I can tell from this value, does it go to -5 or does it go to 0? When I push button 2, what do I get out? Do I get -5 out or do I get 0 out? So this is not a function. And you can see that in the mapping because one value kind of splits off to two different things here. This is not a function. And in my ordered pairs, I notice that my input has two different outputs. My input of 2 has an output of -5 and an output of 0. So from the ordered pairs, I can tell that it's not a function. If I look at a graph, I can quickly start telling, is this a function or not? So which one of these matches my ordered pairs? So I've got -2 and -1 there and there. I've got 1 and -5, so that's there in red and there in red as I'm adding them. I've got 2 and -5, so that's there and there, and I've got 2 and 0, that's there. Oops, this one doesn't have it. So because it doesn't have that extra spot where I'd anticipated it to be, it does not exist there. And so this is the graph for this. And based on this, how could I tell that it's not a function? I'm going to talk about something in the next slide called the vertical line test. Now the vertical line test says that if you can draw a vertical line anywhere on a graph and it only hits once, then the graph is a function. Otherwise, it's not a function. So if I look at this first one, and we're going to focus on this first guy here, I'm going to start drawing vertical lines. And if I draw it anywhere, I'm drawing a whole bunch of vertical lines. And notice, this vertical line only crosses once, this vertical line only crosses once. Everywhere on this graph, all of my vertical lines only cross once. So this is a function. If I look over here, if I draw this, it hits once there, but as soon as I go over here, here is a place where it crosses twice. And because it crosses twice in this, it is not a function. We could also think about it that my input, my x value, has two possible outputs or two possible y values, and that's another reason why it's not a function. So if it hits, otherwise, if it hits more than once, it is not a function. And so we can see that we have a non-function on the right. Here are 3 examples. I just want you to take a quick moment to decide, are these functions or not functions, and maybe use the vertical line test. So quickly looking through, this is a function because every vertical line will only cross once. This too is also a function, and even though it's a little curvy, every vertical line only crosses once. No matter where I'm passing, it is also a function. But this even though it crosses once there is a place, namely right here, where it crosses 3 times. And because it crosses more than once, this is not a function. And so here are 3 examples of the vertical line test helping us show a visual example. All right, we've talked about graphs, we've talked about tables of values, we've talked about mappings, and we've talked about ordered pairs. This is a great time to pause the video, and this is the end of the video actually. This is a great time to stop the video and try these 2 problems out and link all 3 representations, the graph, the table, the map, and the ordered pair. Excuse me, there are 4 representations. Link them all together. And are these functions or are they not functions? And how can you use the visual example for each to show why? All right, in about 3 seconds, I'm going to reveal the answer to this, and then the video is going to be over. So if you haven't yet, please pause the video, try these out, and in 3, 2, 1, answer.